This is the second video in the discrete probability distribution units. If you haven't seen the introductory video, you might go back and watch that video before you watch this one. In this video, I'm going to talk about how we can calculate the mean from discrete probability distribution data. We can use the probabilities to come up with the mean for the random variable that we're focusing on in our probability distribution. And here's the formula that we would use. Mu equals the summation of x multiplied by the probability of x. Again, mu is the symbol for the mean, and that's the population mean, but we're working with population data, and for our purposes for this topic, we're just going to assume everything's a population. Sigma again is a summation operator. X represents the different values of our random variable, and P with x in parentheses is the probability of each x value. Now, if you look at some other sources, you might see some other textbook authors, some other statistician not using the term mean. They might use the term expected value, and the formula could look a little bit different. Instead of mu, they use EX as what they're finding with the same formula. Formula is the same, just some slightly different labeling. So, okay, let's go ahead and calculate the mean from discrete probability distribution data. And we're going to calculate this mean using the car sales data that we talked about in the introductory video. And here's a summary of this car sales data. Again, we have 5 different values of x, we have the probability of x, and then we have a calculated value, which is actually part of the formula. But let's go ahead and bring the formula up, and I'm going to show you 2 different ways that you could do this calculation. Either one would be fine with me, whichever method you prefer. But if we start with the formula, we're going to have multiple terms that we're going to be plugging in. This is a summation of each x value, or each value of x. We have 5 of them. Each x value multiplied by the probability that that x value is going to occur. So we're going to have 5 terms in the first iteration here. And this is what we're going to be doing symbolically. But here's what we're actually doing with these numbers. Our first term, we have the value 0 multiplied by the probability 0.4. Our second term, we have the value x multiplied by its probability 0.27. And when I say its probability, that's the probability of one car being sold in a week. For the value 2, right here, we multiply by its probability, and so on until we've accounted for all the different possible values of x and their probabilities. Now we just need to do the multiplication in the brackets, and once we have the multiplication, we add everything up, and we end up with a mean value of 1.2 cars. The mean number of cars sold by Salem Ford during this 30-month period was 1.2 cars per week. And I said there were going to be 2 methods I would show you for finding the mean for these data. The other method, we have a formula here. You can lay everything out like this, like I've already shown you, or you can just use a summary table like we have over here on the right side of our slide. The summary table again shows the different values of x. It shows the different probabilities of x. Then it shows each x value multiplied by the probability that that x value is going to occur. That's what we have in this third column. And that's what we're adding up to get the mean. So if we have x multiplied by the probability of x for each of these values in our summary table, all we need to do is add all those up, and there's our mean. And just to kind of proof this out, to show you that what we're doing with this approach for calculating the mean really works, let's do it more conventionally. What we've really done in the previous example of what I'm going to do here is we're going to use the weighted mean technique to calculate the mean. With the weighted mean technique, we have a weighting factor multiplied by each x value. The weighting factor is the number of weeks. But in the numerator, we have the first x value represented, 12 weeks at 0 car sales, 8 weeks at 1, 4 weeks at 2, 4 at 3, and 2 weeks at 4 cars sold. In the denominator, we have the number of weeks, which adds up to 30. We do the math for the numerator, divide the numerator by the denominator of 30, we find the same mean that we found using the probability data to calculate the mean. 1.2 cars sold per week for the 30-week period. So, well, that's it for this video. In the next video, we're going to use probability distribution data to calculate the variance and the standard deviation.